In the previous video, we were following a general method for balancing, which doesn't always work. But for the previous problem, we started off by balancing atoms other than oxygen and hydrogen. Once we had all those balanced, we could balance the hydrogen, and then step 3, balance the oxygen. And sometimes we might have to repeat those steps if you have to. So you won't always end up with an overall balanced equation at that point. Now, not every reaction follows this general method. For example, here I have a reaction where an element other than ONH, chlorine, shows up in 2 of the products. So trying to balance the chlorine first is not going to be a very beneficial method. So instead, I could start with something like manganese, and I already have 1 on the left, I have 1 on the right. So the manganese is already balanced. In this example, I'm going to not look at the chlorine. Instead, I could look, for example, in this case, at oxygen. I know I have 2 oxygen on the left, and I only have 1 oxygen on the right. So I need to make a coefficient of 2 in front of the water. That's going to give me a total of 4 hydrogens on the product side, and I only have 1 hydrogen on the reactant side. So I need to multiply this one by 4. Now I can look at the chlorines. I have a total of 4 chlorines on the left. I have 1 Cl2, so that's 2 chlorine atoms. And then I have MnCl2, which has 2 more chlorine atoms. So 4 chlorine atoms matches 4 chlorine atoms. So this is a balanced reaction. Every element is balanced. Combustion reaction, like the previous video and like this example, these are the most common type of reactions where the general method is most effective. So I'm going to start with anything not an oxygen or a hydrogen. So I have 6 carbons on the left, 1 carbon on the right. So I need to make a coefficient of 6 in front of the carbon dioxide. Then I'm going to balance the hydrogen, 14 on the left and only 2 on the right. So I need to make a coefficient of 7 in front of the water. And then the only element left is oxygen. And right now I have 2 oxygen on the left, and on the right, 6 carbon dioxide. 6 times 2, that's 12 oxygen from carbon dioxide, and then 7 more from the 7 waters. So that's a total of 19 oxygens. So there isn't a whole number that I can multiply this O2 by to make 19 oxygens. Instead, this has to be 9.5 as a coefficient. But the rule is a properly balanced equation has to have only whole number coefficients, and they have to also be the lowest ratio. So in this previous example, if I had multiplied everything by a factor of 100, conservation of mass would still apply, but that's not properly balanced. So I need to get this into all whole numbers in the smallest possible ratio, and the way to do that is to multiply every coefficient by a factor of 2 to eliminate that 9.5. And when I do that, my coefficients turn into 2, 19, 12, and 14. And you should go through and count up how many carbons are on the left, how many are on the right. You don't have to write them all down. That takes a lot of time, especially on an exam. But if you do this in your head, you can quickly double check to see that the reaction is properly balanced.